Throughout the morning, we've heard about the incredible promise of exploring intelligence, the potential to deeply understand how humans learn, to use that understanding together with novel computational methods to create new algorithms, and to apply those methods to virtually every scientific discipline and to every aspect of everyday life: finance, transportation, healthcare, social interactions. One might be inclined to infer from this that the impact of intelligent algorithms are mostly still to come, and that impact is high. But in many cases, the impact is already here. Tang Xiao'ou and his company, SenseTime, are a wonderful example of that. An MIT PhD graduate from 1996, Xiao'ou has decades of experience in computer vision and machine learning. I had the pleasure of serving on his thesis committee. His supervisor was one of my first students, and I've been delighted to stay in contact with Xiao'ou ever since. Currently a professor at the Chinese University of Hong Kong and a former lead researcher at Microsoft Asia, Xiao'ou is one of the most visible and influential leaders in artificial intelligence, both within China and internationally. SenseTime, Hong Kong's first unicorn, produces world-leading systems for face recognition and verification and other video analytics by building on decades of careful academic research, and serves as a great example of how robust scientific development of methods can have impact in real-world settings. Xiao'ou is not only conducting world-class academic research and building a cutting-edge company, he's also wonderfully maintaining his long-standing and close ties to MIT. And thus, I'm pleased to note yesterday's announcement of the MIT SenseTime Alliance on Artificial Intelligence, a partnership that will open up new avenues of discovery across MIT in areas like computer vision, human intelligence-inspired algorithms, medical imaging, and robotics. Will drive technological breakthroughs in AI that have the potential to confront some of the great challenges of the world, and empower MIT and faculty, both faculty and students, to pursue interdisciplinary projects at the vanguard of intelligence research. I'm thus delighted to introduce to you Tang Xiao'ou.
Thank you. Thank you, Eric, and thank you, MIT, for giving me this opportunity to speak on this stage. It's really nice to be back home. It's a lot colder than Hong Kong, but I do feel warm. I mean, I talked to Eric, I talked to Anansa, I talked to Josh, and I have this warm feeling. It's because of the air conditioning. First of all, it's such a great honor for SenseTime to form this alliance with MIT and to be part of this MIT Intelligent Quest. I think together we will definitely go beyond just deep learning. We'll go to the uncharted territory of deep thinking. Before I dive into that, let me start with something less deep. Well, I always start my talk with this picture for two reasons. One is he's my son, Samuel, and the second is he's just handsome. And today, I do have a real reason. In a few years, he's going to, apply to college, and perhaps MIT. And we have so many professors today here. I just want you to remember this face. Yes, I'm just joking. Actually, his math score is not very good. It's not terrible, but it's kind of scary. So I don't think he will make it into MIT. We will settle for Harvard. Well, enough kidding. Let me talk about something serious, money. Okay, so this is a global top 10 box office last year for all the movies. On average, they are close to $1 billion each. What is amazing about this picture is that there's one movie among them is from China. It's Wolf Warriors. It's the one right in the middle. It actually beat out Wonder Woman and Pirates of the Caribbean. It's I think 850 million US dollar, which is amazing numbers. I mean, just 20 years ago, if you have 50 million, that's a big movie. But now it's 850 million, and it's a Chinese movie. And all the other movies on this chart is global box office. And this one, even though it's also global box office, but 99% is from China. Why? Why can this movie make so much money? Is it really a great movie? I actually watched it on the airplane. And I think it's okay. I would say it's reasonably reasonable. Then why it makes so much money? Because 20 years ago, nobody in China will pay for a ticket. Not nobody, few will pay a ticket to go to a theater to watch a movie, because you can find a pirate copy anywhere easily. So people are not paying. So why make a movie? But nowadays, people are going to the theaters. They are paying. So we have the, when you have the money, then the creativity will follow. I think that's the reason why we have such a great breakthrough. And it's not just a one-shot thing. It's actually this year, we are breaking the record again with several movies come out, making just a huge amount of money. So when you have this protection of IP, then you have, the creativity and all the new things followed. So let's come back to today's topic. Today's topic is AI, creativity in AI. So when I say the word AI, what are you thinking? Which company, come to your mind instantly? I think we must be all thinking about the same company. I see, Eric is smiling. Great mind think alike. Yes, it's SenseTime. Thank you. Well, instead of laughter, I'm looking for applause here. Again, thank you for the sympathy. So, yes, it's Google. Then why Google? Because Google did spend the money. In 2015, its budget for R&D is $12 billion. They threw away $12 billion just to do something that may work or may not work. And then in 2014, they bought a company called DeepMind, $660 million, 12 people, no product, just play using deep learning to play game, play Go. They could have just hired people one by one. That way it's much cheaper. But they did spend $606 million. That's the value for the people, for the talents. And if they have not done that, they will not be AlphaGo. And AlphaGo really is amazing breakthrough, and it educated everyone on AI. So what do? How do you follow up with AlphaGo? Well, Google followed with AlphaGo 2, then AlphaGo 0. And what about other companies? I think in China, quite a number of companies trying to develop their own Go-playing deep learning algorithms. But if you do that, you're just following the footstep of what Google is doing. In the ancient time, before we have glass, in China, on the windows, they have these papers, paper window. So we have a saying, you poke a hole on the paper window, then you will see what's inside the room. So what AlphaGo did is poke a hole. Then we start to see a lot of amazing things. So if you follow that with another game, another learning network, all you are doing is just poking another hole on the window. You're not seeing anything new. You're just seeing it from a slightly different angle. So nothing really being created. So what is really important is what you follow and also what you have done before AlphaGo. So in 2014, we did something that is not the same, but similar. We developed a computer vision algorithm that can recognize a human face better than human beings' eye. So we break that record. We beat Facebook to the punch and did it first. And in the year follows, when we beat the human eye, the accuracy we did is 98.5, and human eye is 97.5. And in the next year, we improved it to 99.5 with 300 face training. And the year later, we improved it to 1/1,000,000 accuracy using 600 million 60 million data for training. Then the year later, we used 2 billion face data for training. We reached 1/100 million accuracy, which is equivalent to 8-digit password. So we work with Qualcomm form this alliance on AI. And all this great work is done by MIT alumni. Professor Xiao'ou Wang, he's a student of Professor Eric Grimson, also my student, a master student. He came to MIT and went back to Xiao'ou as a professor. Professor Da Hualin, the same, did a master in Xiao'ou, then come to MIT, work with Eric, finished his PhD. Now he's a professor in Xiao'ou. Now let me just show a few work we have done in our lab. The first is to use pictures, to look at the pictures, use face expression and also the gestures of the people, two people in the picture, to guess their relationship. We can do this based on expression or based on gestures. What is it useful for? Because we can just take your picture from on your website, then see which picture you're taking and what is the relationship. If you're taking a picture with the rich people, then will be, the bank will lend you money easier. If you take a picture with a criminal, then, bad luck. So we actually can do this in real time for videos.
But those two do not know how to throw a party.
You see the
I was just
competitive. So the red, red one is competitive, and the green one is friendly. You can see, when they argue,
doing?
the red one will come up.
change these
When
sheets.
they are not,
Why?
then so we
Because
see
it's
this in real
disgusting,
time.
You can't just make up your own rules to suit you
And
for the
I
game.
asked my students to try this on my kids' photos because my kids has a lot of girlfriends. I just want to find out which one is real. The result come back, they're all real. So, but I just tell him that no matter how many friends you have in the daytime, in the evening you can only take one home. So I think it's a sensitive subject for dating. Let me switch to another application, which is less sensitive, politics. I'm not from Russia, so I want to help, not interfere. I think in America, I observed that sometimes people will agree with an idea, but they don't like the messenger. They like the message, not the messenger. So we develop a technology that can help, So if you don't like the messenger, we can just do the face swap, change it to someone you like. Then perhaps it will help. And of course, we do it for both sides. So if you don't like this messenger, then we can switch it to the other messenger. So this is all done in real time. We can also even use your own face. And the next application, sorry. This is, we are watching the Olympics. I think for a long time, you are just cannot really see the real action. So what we can do using this technology is to really pick up the highlights so that you don't have to sit there for 3 hours. Then you just, 9 minutes, then you watch all the things. And this one is we can search for all the kind of videos that you like. For example, this is for disaster videos, and this is for martial arts, and for different type of movies. And this one is trying to use natural language processing to describe the scene, and then come up with the scene of the movie. I apologize for this particular movie I'm using. I don't have time to change. So this is Francis is wearing a dark blue suit and a tie, and he's sitting on the sofa beside Claire. So then we pick up all the things from the movie. The next one is using natural language to describe the scene. So basically, it's like people are describing a sports event using machine. A player in the blue shots, a player in white knocks the ball with the bait. And this one is this is a movie. It's called Once Upon a Time in America. So in this movie, we can detect everything in the scene, including the tables, the players, the actors, actress, almost everything in this. So using this technology, we can analyze the movie. To give a description of what is happening, and also, is it a drama, is it action, everything. And this is, when we are watching the movie, the machine tells what kind of action this is. Is this action, this part is action, or this part is romantic? And this one is picking out exciting moments in the movie. Because of the time, I just skip this next demo. So basically, what we are doing, we are teaching the machines to watch movie for human. So DeepMind is teaching machine to play Go, and we have people to teach a machine to play poker, play game, and we are now teaching them to watch movie. So the machine doing all the fun stuff. What we do, we just do the hard work of research. I think something is wrong here. So let me come back just to the topic of today's topic. I think instead of teaching the machine we have now, it's capable of learning. It's not thinking. So I agree with Josh. He taught today. He said in his lifetime, perhaps we'll never have a machine who can think. Maybe 20 years, or maybe even in my lifetime, 50 years, we can probably never see this. But instead of really to come up with a machine who can think, who is intelligent, perhaps we can think by ourselves. We can think to to build an environment that can really help scientists to solve the problem in AI. And how to help scientists, what scientists need the most. As a scientist myself, I can tell you, the only thing we need is money. So just give us the money and we'll solve the problem. So thank you, MIT, for giving me the opportunity to learn from you when I was a student. And thank you for giving me the opportunity to think with you together in this IQ campaign. Thank you very much.